So I really like to use this equation over using the next equation to get between quantities, and it's because it's so easy to do 14 minus in your calculator. So earlier we calculated a pH of 1. If we had wanted to know a pOH, and most of the time you just want pH, but if we were asked for the pOH, all you'd have to do is over here. So it's just they add to 14. So you do 14 minus either of them, gives you the remaining one. So, it's like subtracting pH from both sides. That's 14 minus pH. Or if I subtract pOH from both sides, then it'd be 14 minus pOH equals pH. So that's just quick little easy subtraction. You'll get to the point where you just really naturally do just 14 minus the number. You don't even hardly think about what you're doing. So if I know that my pH is 1 and I want to know my pOH, that's easy. Just 14 minus 1 is equal to 13. The other thing that I like about this is, especially if you have a whole number, then it's really easy. You can just do that math in your head. Now, if you had like 14 minus 1.22, you would know that your answer is a little bit less than 13 at least, right? So that's helpful also. But it's also easy to type in your calculator, and you're not using like 1 times 10 to the negative something or another when you're doing all these. And then over here, what if I had that the pOH was equal to 13? Well, 14 minus 13 is giving me a pH of 1. So that's using that equation. Now, there's another version of this equation, and it comes from what happens if you were to do 10 raised to all of these things. And I'll show you, I'm about to show you what happens when you do 10 raised to all of those. You end up with this scenario right here. So what I tend to want to do is just go ahead and think of this as a separate equation because they do look quite different. This is related to the kW of water, and we haven't talked about the kW of water, but it's kind of nice to go ahead and have this equation. So this is an equation that will also let us get between H's and OH's. So this is one way to get between H's and OH's. This is the other way if you need to get between H's and OH's. It's just, if you're dealing with pH and pOH, this is the one that's going to be most common that you use much more often. You probably won't use this one as often. But if you were told that H3O plus was 1 times 10 to the minus 1, and you had to find OH, then you would just rearrange this top equation. Get that a little bigger. And you would just say that this divided by H3O plus, because you're trying to solve for OH. And those will cancel. So then you have that OH is equal to 1 times 10 to the minus 14th over H3O plus. So when you do that math, you get 1 times 10 to the minus 14th over this number, 1 times 10 to the minus 1. And so that gives you 1 times 10 raised to the minus 14th divided by, let's just use my EQ. 1 e to the minus 14th divided by 1 e to the minus 1. You don't have to use parentheses in the denominator if you're using the e key. So that tells me that that answer is 1 times 10 to the minus 13th.